Hey, what's up, cybercreed family? So, here's a wild stat that'll blow your mind. Every single minute, and I mean every 60 seconds, over 720 hours of video content gets uploaded to YouTube. That's like 12 hours of video every single second. And honestly, if you tried to watch all the content uploaded in just 1 minute, it would take you literally 30 days of non stop binge watching. Meanwhile, your phone starts crying when you try to record a 4K video for more than 10 minutes because it's running out of storage. So, what gives? Today, we're diving deep into YouTube's absolutely insane storage architecture, how they handle this tsunami of data without breaking a sweat, while your 128 GB phone acts like it's storing the entire Library of Congress when you download 3 Netflix shows. So let's talk numbers for a second, because this is where things get absolutely bonkers. YouTube isn't just dealing with 720 hours per minute. We're talking about a platform that's been running for nearly 20 years, accumulating exabytes of data. And no, that's not a typo. An exabyte is a billion gigabytes. To put that in perspective, if you had a terabyte hard drive, which already sounds massive, you'd need a million of them to store just 1 exabyte. But here's what's really wild: YouTube doesn't just store one copy of each video. Oh no, that would be way too simple. They store multiple versions of every single video in different resolutions, different formats, and different compression levels. So that 10-minute cat video you uploaded, YouTube is actually storing like 15 different versions of it. It's like having 15 different size t-shirts for the same design, except each t-shirt costs money to store, and you need all of them ready to go at any moment. Now you might be thinking, okay, but they're Google. They just throw money at the problem, right? Well, yes and no. Even Google can't just burn cash on infinite storage. They've had to get incredibly smart about how they handle this, and that's where the real engineering magic happens. So, how does YouTube actually store all this stuff? The secret sauce is something called the Google File System, or GFS, and it's honestly one of the most brilliant pieces of engineering ever created. Instead of having one massive hard drive somewhere, which would be like trying to fit an elephant in a shoebox, they distribute everything across thousands and thousands of servers in data centers around the world. Think of it like this: imagine you're trying to store a massive jigsaw puzzle, but instead of keeping all the pieces in one box, you split them up and put different pieces in boxes all over your house, your neighbor's house, your friend's house across town, and so on. That's basically what GFS does, except instead of puzzle pieces, it's chunks of your video data, and instead of houses, it's data centers in Iowa, Belgium, Singapore, Chile, and dozens of other locations worldwide. But here's where it gets really clever. They don't just store one copy of each puzzle piece, they store multiple copies in different locations. So if the data center in Iowa gets hit by a tornado, or the one in Singapore has a power outage, your video is still safe and sound in multiple other locations. It's like having backup copies of your backup copies, except it all happens automatically without you ever knowing about it. Now, storing multiple copies of everything sounds expensive, right? This is where YouTube's compression wizardry comes in. And honestly, this stuff is so smart, it makes me a little emotional. They use advanced video codecs, basically algorithms that squeeze video files down to a fraction of their original size while keeping them looking good. The main players here are VP9 and AV1, and these aren't just your average compression algorithms. VP9 can reduce a video file by about 50% compared to older standards while maintaining the same quality. But AV1? This thing is absolutely bonkers. It can achieve even better compression than VP9, sometimes reducing file sizes by 30-50% more while actually improving the visual quality. Let me put this in perspective. Remember when you tried to email a video to your mom and it was too big? YouTube takes that same video and compresses it so efficiently that they can stream it to millions of people simultaneously while using less bandwidth than you'd need to send it as an email attachment. It's like having a magical shrinking machine that makes things smaller but somehow better at the same time. And here's the kicker: they don't just compress it once. For every video you upload, YouTube creates multiple compressed versions at different quality levels. So when you're watching on your phone with a spotty connection, you get the highly compressed version. When you're on your 4K TV with gigabit internet, you get the premium version. It's like having a restaurant that automatically serves you the perfect portion size based on how hungry you are, except it's all happening in milliseconds. But compression is only half the battle. The other half is making sure your video loads instantly no matter where you are in the world. YouTube leverages Google's absolutely massive global infrastructure. We're talking about data centers on every continent except Antarctica, and honestly, they'd probably put one there too if penguins watched more YouTube. These aren't just regular data centers either. Google's facilities are engineering marvels that would make NASA jealous. They use custom designed servers that are optimized specifically for video storage and streaming. They have advanced cooling systems that use AI to predict and adjust temperatures in real time. Some of these data centers even use seawater for cooling, which is both environmentally friendly and incredibly efficient. The redundancy here is absolutely insane. Every piece of data is stored across multiple data centers, multiple servers within each data center, and multiple drives within each server. It's redundancy all the way down, like those Russian nesting dolls, except each doll is a backup of the previous one. And the networking between these data centers, Google operates their own private fiber optic network that spans the globe. They literally laid their own cables across ocean floors to connect their data centers. It's like having your own personal internet that's faster and more reliable than the regular internet the rest of us use. Now, here's where things get really interesting from a performance perspective. YouTube doesn't just store your videos in data centers, they use something called a content delivery network, or CDN, to get content as close to viewers as possible. Imagine if every time you wanted a pizza, you had to drive to Italy to get it. That would be ridiculous, right? Instead, you have pizza places in your neighborhood. That's exactly what YouTube CDN does. It puts copies of popular videos in servers that are geographically close to where people are watching them. So when someone in Tokyo wants to watch a video, they're not pulling it from a server in Iowa. They're getting it from a server in Japan, or maybe even from their internet service provider's local cache. This is why YouTube videos load so fast, even though they're massive files. The content is literally sitting just a few miles away from you. The intelligence behind this system is mind blowing. YouTube's algorithms predict which videos are going to be popular in different regions and pre position them accordingly. It's like having a crystal ball that tells you which movies to stock in each video rental store, except it's happening automatically across thousands of servers worldwide. So let's talk money for a minute, because this whole operation isn't cheap. YouTube spends billions of dollars annually on infrastructure, but here's the thing: they've made it economically viable through some incredibly smart strategies. First, they use commodity hardware wherever possible. Instead of buying expensive specialized servers, they use thousands of relatively cheap machines. If one breaks, who cares? There are thousands of others ready to take over. It's like having an army of Honda Civics instead of one Ferrari. Sure, each individual car isn't as fancy, but collectively they can handle way more traffic, and if one breaks down, it doesn't matter. Second, they've optimized everything for efficiency. Their data centers run on renewable energy. Their servers are custom designed for maximum performance per watt, and their cooling systems are so efficient they'd make your home air conditioner weep with envy. But the real genius is in how they handle less popular content. Not every video needs to be instantly accessible from every location. That cat video you uploaded that got 12 views, it might be stored in just a few locations, and if someone wants to watch it, the system can retrieve it quickly, but doesn't need to keep copies everywhere. It's like having a library where popular books are on every shelf, but rare books are kept in the back room, still accessible, but not taking up prime real estate. So why can't your phone do the same thing? Well, it's actually trying to in a much smaller way. Modern phones use compression, they have redundancy through cloud backups, and they even have some smart storage management. But they're working with fundamentally different constraints. Your phone is a single device with limited storage, limited processing power, and limited battery life. It can't distribute data across multiple locations, it can't compress videos as aggressively without draining the battery, and it definitely can't predict what you're going to want to watch next and preload it. Plus, your phone is trying to be everything: camera, computer, gaming device, communication tool. YouTube's servers have one job: store and serve videos. They're specialists, while your phone is a generalist. It's like comparing a Swiss Army knife to a professional chef's knife. Both are useful, but they're designed for different purposes. Looking ahead, things are getting even more interesting. YouTube is experimenting with edge computing, where processing happens even closer to users. They're exploring new compression algorithms that use AI to understand video content and compress it more intelligently. and they're working on storage technologies that make today's systems look primitive. There's also some fascinating work happening with predictive caching, using machine learning to predict not just what videos will be popular, but when and where they'll be popular. Imagine a system that knows a video is about to go viral before it actually does, and pre-positions it accordingly. So what can we learn from YouTube's approach? First, distribution is everything. Don't put all your eggs in one basket, whether that's data storage, business operations, or anything else. Second, compression and optimization matter more than raw capacity. It's better to be smart about how you use resources than to just throw more resources at the problem. Third, redundancy isn't just about having backups, it's about having backups of your backups and making sure they're in different places and different formats. And finally, the real magic happens when you can predict what people want before they know they want it. For those of us building systems, YouTube's architecture teaches us that scale isn't just about making things bigger, it's about making them smarter, more efficient, and more resilient. It's about building systems that can handle not just today's load, but tomorrow's load and the day after tomorrow's load. So there you have it, cybercreed family, the incredible engineering behind YouTube's seemingly infinite storage. From distributed file systems that span the globe to compression algorithms that would make mathematicians cry tears of joy, to data centers that are basically technological cathedrals, YouTube has built something truly remarkable. The next time your phone complains about storage space, just remember, it's not that your phone is bad, it's that YouTube is operating on a completely different level. They've solved problems that most of us can't even imagine having, using technologies that push the boundaries of what's possible. What do you think about YouTube's storage architecture? Are there any aspects you'd like me to dive deeper into? Let me know in the comments below. And if you enjoyed this deep dive into the technical wizardry that powers our favorite video platform, make sure to hit that subscribe button and ring the notification bell. Thanks for watching, cybercreed family, and I'll see you in the next one.